All right, hello again, my wonderful learners. Okay, so we have this decimal number, and I want to get the place value of each of the number in this, each of the digits in this. This is a decimal figure. Okay, so if we have, this is 0.00347. 0.00347. At a glance, you can see that this decimal notation here, immediately after the decimal notation is a 0, and after the 0 is another 0. The first non-zero is actually at the third position here. That's where we have the first non-zero. So if you're asked how many significant figures are in 0.00347, it's very simple. Know that a significant figure begins where you have your first non-zero, and a non-zero should be 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all non-zeros. So the place where we have the first non-zero is this third position. 1, 2, 3. So that means we have 3 significant figures here. 3 SF. Yes. Then for the number of decimal places, the number of, you start counting the number of decimal places from the first position immediately after the decimal notation. So here we have the first position, the second, third, fourth, fifth. So we say that there are 5 decimal places. So while we have 3 significant figures in 0.00347, while there are 3 significant figures here, there are 5 decimal places. A lot of us, we mix this thing up a lot. Some of, especially our third, fourth graders, fifth graders. Let me shield the third graders from this, because they don't do this until they get to fourth grade for some schools. All right, so please take note that in most cases, in fact almost always, the number of significant figures does not always translate to the number of decimal places. I see most learners, most students, right, because there are 3 significant figures, they will go and say there are 3 decimal places too, or because there are 5 decimal places, they will say there are 5 significant figures. So the point is, the number of decimal places does not always translate to the number of significant figures you have in the number. The significant figure begins from where you have your first non-zero. All right. Oh, that's just by the way, just to help us, learn as we proceed. But what I want us to do with this is to learn the positioning, the name we give to each of the position after the decimal point. Remember, we're talking about after the decimal point too, because the focus is decimal numbers. And I would like us to note that what happens after the decimal point is not the same as what happens before the decimal point. Before the decimal notation, we have integers, we have whole numbers. But our focus is what happens after the decimal point. And the way we arrange the place value for decimal numbers is not the same as whole numbers. So the whole numbers own, if you watch my videos, the previous videos I did, you'll see that, the way we arrange that of whole numbers is not the same as that of decimals. So if you want to refresh your mind, or you are just seeing this for the first time, just check, you see where I did place value for whole numbers. All right, so let's arrange this, please. I'm interested in this point, from this point here, after this place. 1, 2, 3, 4, 5. That's my interest. Okay, I said the first house here, immediately after the decimal point, my dear, the first house is the 10th. This is the 10th, and this is the 100th. This is the 1000th. This is 10,000. And this is So please, let's take note of this. These are the names given to these positions. I also want to stress this. Just allow me to stress this. I also like to stress that this 10th house you are seeing here is the biggest house. The 10th is bigger than any other house as you go this way. So the 10th is bigger than the 100th. The 100th is bigger than the 1000th. The 1000th bigger than the 10,000th. The 10,000th bigger than the 100,000th. So as you keep going inwards, as you keep moving like this, the size or the scale, the size of the decimal number drops. Take note of that. So in 0.00347, this 3 here is the 1000th. But because this is the 10th, let's do this quickly. We have 0 here for the 10th. So this is 0/10. 0/10 is 0 divided by 10. Any number you divide by 0, anything divided by 0 multiplied by 0 is 0. So this is 0 here. This is also 0/100, which is 0, please. Now let's look at the thousandth. We have 3 here for the thousandth. 3. So this is 3/1000. And 3/1000 is the same thing as you saying 3 divided by 1000. Remember, this 3 here, standing here, because you're not seeing any decimal point with this 3, we assume that it's not an assumption, there's an invisible decimal point here. So we're going to use these 3 zeros we have to move this decimal point 3 steps forward. And we're going to move 3 steps inwards, backwards. Please, I beg your pardon. This is a backward move and this is a forward move. So that what we have here is 0.003. This is, so that 3/1000 is the same thing as 0.003. So that in 0.00, this is 0.003. Then for this one, we will have 0.004. And for the last one, the 100,000, it will be 0.00007. So we are asked to give the value of the individual digits in this set here. So it is important that we take note of this. What have I said? I've identified the number of significant figures here and the number of decimal places and the name of each of the position for this decimal numbers. Why am I interested in this? We will need this if we must arrange figures or these decimal numbers in ascending order or in descending order. Continue to practice. I'll see you again in my next video.